Hi friends, today we are going to learn brute force design technique. This is one of the technique, okay, we are going to apply to solve the problem, right? Now what is the brute force technique? Remember that brute force technique is also called a straightforward approach to solve the problem, and problem solutions is depends on problem statement itself. Okay, say as for example matrix multiplications, right? This problem itself is saying that what we are supposed to do, right? We are going to read two matrix and perform multiplications, right? Selection sort, we are going to perform sorting based on some selections, like we are going to find out the minimum elements and accordingly we are going to swap the values. Similarly, we are having pattern matching, that is also called string matching. It means what? We have a given text, main string, and we have a pattern, right? We are going to check that pattern is present or not. Bubble sort, right? Bubbling, finding the largest element and shifting towards right, and one by one after iterations we'll come to know that what is the sorted elements are. So basically what I am trying to say that brute force technique is a straightforward approach to perform the task, right? Under this algorithm technique, we have three algorithms as per your syllabus. One is selection sort, sequential search, string matching algorithms and its complexity. So let us learn first what is selection sort. So name itself is selection sort, right? It means we are going to perform some sorting, right? And based on the given input, whether input is in a random order, we are going to get outcomes as a sorted elements. Say as for example, we have elements like 10, 5, 20, 3, 2, 8. Now, we know that these elements are not in ascending order or descending order. Generally, when person asks you to sort the element, we'll go for ascending order. So, how many number of elements? First, we're going to read how many number of elements we have. 1, 2, 3, 4, 5, 6. Number of elements are 6. Then you have to read the element one by one. So we need arrays and we are going to read these elements, right? So let us have this element index is 0, 1, 2, 3, 4, 5. So number of element is 6, 1 minus 1. Total index is, maximum index is 5, 0 to 5. And name of array, say it is A is a name of array. Now we can see that in this particular case, right, in random elements 2 is minimum, right? So in selection sort, when you are performing the selection sort, right, we are going to find out minimum element. We are going to find out minimum element in the given list. So we are going to compare 10 with 5, right? 5 is minimum, 5 and 20, 5 is minimum, 5 and 3, 3 is minimum, 3 and 2, 2 is minimum, 2 and 8, if you are going to compare, 2 is minimum. So we got the minimum values as a 2. So that minimum values must be come at the first position. When you are going to arrange this element in ascending order, these 2 should come at the first position, right? It means what? Find first minimum element in the given list, swap with the first position's element. Similarly, second time, find next minimum element and swap with the second position's element. Find the third minimum element, swap with the third position's element. And these iterations will be performed again and again in order to find out the final answer. So let us see that. What you are going to do. And after that, after one iterations, I am going to write the code. So first what will happen, we will consider this is a minimum element. So what are we going to consider it here? We are going to consider mean index as a 0, right? So we will be running 2 index in order to not to get confused. So say it is I pointer. So we are going to write mean is I is nothing but initial value 0, index 0, and another variables will be having it here, say j element. So j element will take next of I, j element will take next of 5, because we are not going to compare 10 with the 10. We are going to compare 10 with other elements such a way that which is the minimum we can find out. So let us see that next element pointer will be j, right? So j pointer is what? I plus 1. Now we are going to compare a of j with a of mean. What are we going to compare? We are going to compare if a of j is lesser than a of mean. Now you can see that a of j means j plus j, what I said you, j is here, means I plus 1, next element 1. So it is 1. A of 1, what is value? 5. Is lesser than a of mean. Mean initial index I said you that 0. So a of 0 is 10. Is 5 is lesser than 10? Yes, it is true. In that case, just you are writing new mean values. Mean was I. Now we got new mean values. That mean is j now. Mean is j now. So we got another mean values. Similarly, now we are at here. This value is minimum. Now this element 5 we are going to compare with the next element. Okay. So 5 and 20 we are going to compare. Still 20 is mean, so we are not going to update these values. Now 5 with 3. 3 is mean. Based on this, we are going to update that values. Mean is 3. Similarly, 3 and 2 is minimum, we are going to update. So we are going to learn this one by one. So let us see that how we are going to project it. So first we are going to write selection sort, right? And we have array's name and we have number of elements that you can keep it, right? Or just we are going as it is, as we have done in previous examples, with parameter or without parameters. So both the way we can perform. But here I am trying to tell you is how you are going to write the algorithm for selection sort. So let us see that. If you have here int a of I, right? First loop, what I said, I, right? I will go again and again till last element minus 1. So this is n minus 1 and this position will be lesser than n minus 1. So we are going to write it for I is equal to 0, I less than n minus 1. If you are writing I less than n minus 1, basically I pointer maximum is n minus 2 and I plus plus. In this, we are going to consider mean values, right? First, what I said, mean value will be considered based on I element. So we are going to consider mean. Mean is equal to I, right? Thereafter, we are going to use another for loop for j is equal to what I said, j is I plus 1. We are not going to compare with the same elements. So j is equal to I plus 1, j less than. Remember that j will go till last. So n was 6, 6 minus 1 is 5. So till last, till we can say either you can write j less than n, it means our maximum will be j 5, or if you are writing equal sign, you write it n minus 1. J plus plus. What basically you are going to do it in this? We are going to perform the task if a of j is lesser than a of mean. Then we are going to update the values mean is equal to j. So this will repeat. This will repeat again and again, again and again. If condition is true, mean value will get updated. And finally, we find what is the minimum values in the given list, right? Once you got that mean position means what is the mean values here? Minimum element is 2, but what is position of that element is index is 4th. So here we will get mean as a 4. Once you got that, what I said at the beginning, we are going to swap these two with 10. These two with 10. Right? For that, we require swapping of the elements. So out of this for loop, we are going to write swap. Right? What are you going to swap? Swapping between A of mean with A of I. A of mean with A of I. So just you write A of I comma A of mean. So this is all about your selection sort. At the place of swap functions, even you can write it. If you don't want to write like this, because this becomes swap as a functions, we need to define the swap value, swap functions. Otherwise, we can write it at the place of out of this for loop. For this, we can write temp is equal to A of I. A of I is equal to A of mean, and A of mean is equal to temp. So that we can do it, right? For finding swapping of the elements, right? While you are going to exchange the elements, we can write temp is equal to A of I is equal to A of mean is equal to temp. Now, let us see that how you are going to use this algorithm to perform the task and get all the element in sorted elements. So here remember that here we have elements 10, 5, 20, 3 to 8. We have 10, 5, 20, 3 to 8. Yeah. So just I am writing 0, 1, 2, 3, 4, 5. Here initial values we are having I, and j will start from here, right? As per code what I said, j is I plus 1. J is I plus 1. But before that, what will happen here? We are going to write mean values. Mean is a variable. We are going to write mean is equal to I. And what is the value of I here is, we are talking about the index. J is 1, I is 0. So it is 0. Now, based on that algorithm, so you are going to compare A of j with mean. So in this particular case, A of 1 is 5. A of mean, A of 0 is 10. 5 and 10 you are going to compare, right? Whether A of j, is it 5 is lesser than A of mean 10? Yeah, it is true. If it is true, then we have new mean values. Mean is equal to j. And what is the value of j is? J is 1. Similarly, now we can see that in this function, still we are not completed this loop. Now j will increase. Again you are going to perform the task. J will increase till n, and we are going to perform the task again and again. So let us see that j increases. Now j came to 2. So now new j value is 2. And you are going to compare again same things. If A of j is lesser than A of mean or not. Look, A of j, A of 2 is 20, lesser than A of mean, A of 1 is 5. Is it true? No, it is false. Means we are not going to assign the values, right? 20 is not lesser than 5. So j, even in case of failure case, j will increase. Now j is 3. J is 3. Then again we are going to check this condition. A of j, A of 3 is 3. If 3 is lesser than A of mean. A of mean, we have not changed the mean variable. Mean is remain j is equal to 1. So 1, A of 1 is 5. Is 3 is lesser than 5? Yes, it is true. If it is true, then we got new mean values. What is that? Mean is equal to A of mean is equal to j, and what is current position of j is 3. J is 3. So now you got new mean values. Thereafter what happened? Again we'll go and check by increasing the value of j. J becomes 4. Once j becomes 4, let us check again. What is a of j? A of 4 is 2. Is 2 is lesser than a of mean. Mean position is 3. A of 3 is 3. Is 2 is lesser than 3? Yes. Condition is true. If it is true, then again you are going to write mean is equal to j. And what is the value of j? J is 4. Now, again there is a scope of increasing j values. So j becomes 5 and a of j is 8. So you are going to write if a of j is 8 is lesser than mean is 4. A of 4 is 2. Is 8 is lesser than 2? No, it is false. So mean is remain 4 only. Right? Again j increases. Now j becomes 6. Now when j becomes 6, all of you please concentrate. J started with 1. J has to go till j lesser than n, and value of n is 6. So maximum value of j should be lesser than 6. That is what? J maximum values should be lesser than equal to 5 only. So it started from 1 lesser than j till 5 is true case. A moment you are going for 6, condition fail, it will come out from this. Once it will come out from this loop, there is a swap statement. Swapping between a of I with a of mean. A of I with a of mean. So let us see that. What is a of I and a of mean? So a of I is remain at 10th positions. A of mean is 4. A of 4 is 2. We are going to swap it. So once we do swapping, what will happen? 2 will come at first place, at the place of ith, and thereafter 520 will be as it is. 520 is as it is. Thereafter 3 is there, right? 3. Now at the place of 2 we got 10, because 2 and 10 got swapped, and last element was 8. Yeah. After first iterations we got new values, while we can see that this 2 is the minimum elements that is already been swapped, already been sorted, sorry, right? So rest of the element again we need to perform the same task. How it will happen? Let us see that code. What it says that once we have done with these iterations, right, we have to go and increase the value of I. If we increase the value of I becomes 1. Once I becomes 1, mean becomes 1. Okay, so starting position of mean will be 1. So let us see that this is index 1, 2, 3, 4, 5, and here is I, and j will start I plus 1. As per the concept, j will start from the next element, right? And mean is I is 1. Initial value. What is j value? J start from 2, that is called I plus 1 is 1 plus 1 is 2, and I initially is 1. So let us see that again you are going to do the same work. Is 5 is lesser than 5 is mean positions, 20 is j positions, and what was the one time I will write it in these iterations, that if a of j is lesser than a of mean, then if it is true, then you are going to write mean is equal to j. So let us see in this case. J is here, a of j is 20, where j is 2, a of j is 20, is lesser than 5, a of mean 5, no, it is false. So you are not going to update this, it will remain mean is same values as a I. Now again you go for j is equal to 3, pointer is increases. J is here now. If J increases, in that case what will happen? Again we will write A of J. A of J is nothing but 3 is lesser than A of mean, A of 1. What is the value of A of 1? Is 5. Is 3 is lesser than 5? Yes, condition is true. In that case, we are going to write mean is equal to what? J. And what is the value of J? J is 3. So mean is 3 now. Mean was 1, now mean is got updated, mean is 3. Again, J increases, so J becomes 4. And we are going to compare whether 10 is lesser than 3. Is 10 is lesser than 3? No, false. So again J increases, J becomes 5. And we are going to say that whether 8 is lesser than 3? No, false. So at last we come to know that what is the mean values? Mean is 3 only. And what is the A of mean? A of mean, that is A of 3 is 3. So we got A of 3 as a final mean values. Then what is next? Next is, once you found the mean values, then you are going to swap with I values. And what is I values? 5. A of 1 is 5. 5 and 3 you are going to swap. Once we will done with the swapping, 3 will take the position of 5 and 5 will go to the third positions, and hence again we have to perform the same task. So let us see that after swapping what will happen? 2, 3, right? Then you have 25, we have 20, we have a 5, we have a 10 and 8. You have 10 and 8. Now we can see that these two element is already sorted. Now I is increases. I came to here, J from very next positions, and initial mean values we have considered mean is equal to I, that is 0, 1, it is 2, 3, 4, 5. So mean is 2 now. And what is J? J is 3 now. Again you are going to compare. For J is equal to 3, A of J is A of J less than A of mean. We are going to compare. Okay. So A of J is 5 is lesser than A of mean 20. So condition is true. Hence mean is J. And what is J value? J position is 3. So it's got updated. Similarly, when J is equal to 4, again you want to check. If J is equal to 4, then 10. So you are writing is 10 is lesser than A of mean. A of mean is now A of 3 is 5. Is 10 is lesser than 5? No, it is false. J is increases to last. Is 8 is lesser than 5? 8 is lesser than 5? No, false. So there is no scope. Hereafter J becomes 6 and hence we are going to terminate it, and we got that mean values. What is mean values? Mean is 3 and A of 3 value is 5, and that must be swapped with, see here, out of this selection sort. Select the next minimum element, swap with the ith element. That is why selection sort. So we are going to swap it. After swapping, what will happen? We got 2, 3, we got 5 is already ascending order. Then we have a 20, 10, 8. So 20, 10, 8 we are having the array index 3, 4, 5. So we got 3 element in sorted, 3 element is left out. In this, again this is the minimum element, right? Initial I values, this is J values, and you can see that is J is lesser than I. Yes, condition is true. So this is going to be the next minimum element. Again we are going to compare this and this, 10 and 8 similarly, which is minimum element. So we got here 8 is minimum, and what is position of mean is 5. right? So now this 8 we are going to swap with 20 because among this 8 is minimum. So 8 is going to swap with the 20. Hence we are getting 8, 10, 20. So this will be also in sorted order. And finally we have to consider this is I, this is a j, and that is why look here we have 10, 20, index is 4, 5, right? And this is I position, this is the j positions. So we will remember that in previous citation what I said, I pointer will be 1 less than j pointer, right? And easily we can compare it without reaching I from beginning to the last positions. Only j will go till last, I not necessary to go, right? Even if you are writing till last, you will be getting the same answer, that I will tell you. Here is initial mean is this. So you are going to compare, is j is lesser than mean, is 20 is less than 10? No, it is not, right? It is false. Hence mean will be remain mean, right? So we are going to compare 10 and 10, we are going to swap. So hence our final answer will be 10, 20, and here we have a 2, 3, 5, 8. So these all elements are in ascending order. These all elements are in ascending order by applying selection sort. So let us see one more things I wanted to tell you that in a code, yes, here we written I is equal to 0, I less than n minus 1, I plus plus. J is equal to I plus 1, j less than n, j plus plus. Even friend, if you are going to write here I less than n, you will be getting the same answer. Even you are going to write here j is equal to 0, j less than n, j plus plus, right? Then what will happen? Number of iterations will increase, but at last you are going to get the same answer. See here, if you are writing here n minus 1, we are decreasing that many number of comparisons, right? Hence we are trying to reduce the time complexity. You remember the time complexity class, I said you our tendency is not only to get the solutions, but we are going to think how effectively we are going to write the programs which will take lesser amount of time to execute, right? So in this case, this is efficient one, it will take lesser amount of task, right, time to perform the work, and will get finally sorted element in ascending order. Now for time complexity, if you remember my previous class, what I said you, we need to decide first whether it is recursive or non-recursive. And for non-recursive I said if it is for loop, while loop, do while loop, then go with recursive, non-recursive concept. If it is a function calling itself recursively, then you go for recursive functions, mathematical analysis for recursive functions. So in this particular case, we can see that this is the case of non-recursive algorithms. Hence time complexity will be T of n is equal to summation of I is equal to first loop, I is equal to 0 to, all of you can concentrate here, I is equal to 0 to I less than n minus 1. It means what is not equal, equal to will be there n minus 2. So here is n minus 2 and here is n minus 1. So that part consider first, then you go for time complexity. So here is last value of I is n minus 2. Similarly j is start from I plus 1 and it will go till n minus 1. Basic operation is 1, right? That is comparisons between A of j with mean element. So what I said first, upper limit minus lower limit plus 1 in the case of non-recursive algorithms, and we have already practiced this in a previous class. Upper limit is n minus 1 minus lower limit and plus 1. So once we will do the simplifications, what will happen? I is equal to 0, n minus 2, n minus 1 minus I minus 1 plus 1. So we will see that this term is cancelled now, and here we have I is equal to 0, n minus 2, n minus I minus 1, n minus I minus 1. Now what we're supposed to do? Since this term is depends on I, we'll put the value of I one by one, right, and see the results. So in this case, just put the value of I. Minimum value is 0, 0. So this value will give you n minus 1. Similarly, next value is 1. I is 1. So this value will give you n minus 2 plus, right? When we are giving n minus 2, n minus 2, n minus n minus 2. Look, n minus 2, right, minus 1. So we will simplify this. N minus minus plus 2 minus 1 got cancelled and we got 1. So last value is 1. So before this it will be 2. So this is basically sum of n minus 1 natural number, 1 plus 2 plus 3 plus n minus 2 plus n minus 1, sum of n minus 1 natural number. And what is the summation? N into n plus 1 divided by 2. Here n minus 1 terms we have, n minus 1 term, hence formula will be T of n is equal to n minus 1 plus 1 divided by 2. So this got cancelled and finally we are getting n into n minus 1 divided by 2. Hence time complexity of this is theta of n square. Theta of n square, because it is quadratic and we have learned in the previous chapter that if it is n into n minus 1 divided by 2, it is a quadratic equations, and in that case we can write it is theta of n square. Time complexity of selection sort is theta of n square. Fine. So we'll stop here. Selection sort, we learned how to write the algorithm for selection sort and how to sort the element in ascending order by using selection sort algorithms, as that is written based on brute force technique. Next we are going to discuss pattern matching. Reason is, next topic is sequential search, and sequential search we have already completed in the previous chapters, right? And there we have discussed sequential search, best case, average case, worst case, complexity of sequential search. So hence we are going to discuss pattern matching algorithms.